Hi folks, let's talk about dates in this lesson, and there's some interesting properties with dates that you may or may not know about. So we're going to dive into those, and then we're going to take a look at a whole bunch of common formulas that you'll find really useful when you're working with dates, especially if you're working with Google Analytics data. So I have here a sheet, and in this cell here I have a date, and what I want to do is just explain to you how dates are actually stored in a spreadsheet first. Now, this might just look like an ordinary date, the 6th of October. It's in US format with the month first. But in fact, dates are stored as serial numbers. So they're actually 5-digit numbers that are stored by the spreadsheet and can then be used in calculations. Because, for example, we can do things like we can say what was the day before by just taking one away from our date, and it will give me the day before, the 5th of October. And the reason it can do that is because this number A1 is actually, this date rather, A1 is actually a serial number. So let me just, if you don't believe me still, let me just show you I want to copy this 3 times. And this one here, I just want to show you what happens when we change the format of our dates. Then I can change it from a date to a date time. And you see now that it just adds that 7:30 then. So it's 7:30 in the morning on the 6th of October. It's still the same. It's exactly the same, because if you remember, I copied that one down, and again, this is exactly the same, but this time what I'll do is I'll change it to a number, and you can see it's 43014 spot 31, and then this one here, I'll change it again to a number, and this time just remove those decimal places, and they are all representing the same date to the spreadsheet, because if I now take all of them and I subtract 1, you saw that was the 5th, that was the 5th at 7:30, and if I format them all to be short dates, you'll see that they all give me the 5th of October. So they can all be subtracted and then turned into a dates by format. So it's really important to understand that there's what you see on the screen with dates, and then there's the underlying data, which is this serial number. The whole number part, so that's this part here, the 43014 is the date. And then the decimal place part, which is at 0.3125, is actually the time period. So if we had just the 43014, then I go and now turn that into a date time format number. If I look at date time, you'll see it gives the date time now 0000. So that's because there's no decimal places now in that number. So if we go back and just undo that, if I now put in a spot 999, then that gives me that's the minute before midnight if we go and look at the date time again. So it's 23, 59 and 51. So actually if I added one more 9 and then tried that again, then we'll get the second before midnight. And so you can see how dates are working. They're just numbers, they're serial numbers with the decimal places representing time and the whole number part representing the actual date piece. And so once we know that, if I want to remove the time from a date time, which is quite common, you often get data which looks like this and you're not really interested in the granularity of the time, you just want the date. We can use this quick formula called int, and that will just remove the time piece, the portion of the date. So if we now format that as a date time, you'll see it's a 000, and obviously then we can work with it as just a short date format. So it's really important to make that distinction between whether you're just formatting, as we did here, the date, and it still has the underlying time involved, or whether you're actually fundamentally altering the data underneath. Because in this one, for example, with this formula int, what we're doing is rounding a number down to the nearest integer. And so that's a good way of just always chopping off the time at the end of the date. Now, the reason dates are in this serial format is because that's how the original Lotus 123 spreadsheet program worked, and then subsequently the very first editions of Excel implemented this system. And what's interesting is that the date should start with, the idea was that the very 1st of January 1900 would be number 1, and then you would work forwards from that point with your serial numbers. But there was an error in that original Lotus 123 program that the engineers thought that the year 1900 was a leap year, so they had a 29th of February in that 1900 year. And of course, there was no 29th of February in the year 1900. And so if you look now, Excel still starts with 1900 as 1, but Google Sheets actually starts with the first 1900 is actually the number 2 in Google Sheets, because they made sure they got rid of that bogus 29th of February number in 1900. So that's a little sort of historical aside, but if we do look at that quickly, just to show you, if we look at 1/1/1900, and then let's take a look at the last day of the 1899 as well, the 19th century. If I copy all these and then let's turn them into numbers, you'll see what I've been talking about. You'll see that this is, the number 1 is actually that 31st of December 1899, and the number 0 is the 30th of December. If I drag that down one more, then they just become negative numbers, and they can still just be used in your calculations, but something to be aware of. So dates are actually just numbers behind the scenes. So that's enough talking about numbers. Let me show you one last common scenario that we might do with dates, or a couple of formulas actually that are quite common with dates, and then we'll see how we might use them in the Google Analytics scenario. Okay, so let's take a look at this common scenario. You might have data where the format looks like this, and to the human eye it's pretty easy to recognize that as a date. It's the 30th of September 2017, but in this format Google Sheets can't use this as a formatted date, because if you recall, we said that we could add a number 1 and it would change that, it would increment the day by 1, but in this case there's no 31st of September, and Google Sheets is just treating this as a regular number, 20,170,931. So that's obviously not our intention. So what we need to do is use the formula called date, and then we're going to supply it with a year, a month, and a day, and it will convert that into the correct serial number. So the year is going to be the first 4 digits, so we'll use left. Click that, 4 just to extract. Then we'll use mid to get hold of those middle 2. So let's type in the word mid, reference the cell again. We're going to start at position 5, so that's 1, 2, 3, 4, 5. That's the 0 we go in. We're going to grab 2 digits, and then finally we're going to grab the right. We're going to grab the right 2. And then I'll close parentheses, and you see now that's actually converted that into the correct serial number for me. So let me just confirm that's a date for you as well. And there we go, 30th of September 2017. And if we copy that formula underneath now to grab a date, you'll see that it correctly converts it to the 1st of October 2017. So that's an important point again. It might look like a date to your eye, but if it's not stored as one of those serial numbers, it's not being treated as a date by the spreadsheet program. Okay, let me show you some other formulas that are really useful. Let me show you now. I just type the word now with the parentheses, and what that does is give me today's date with the time right now when I typed this cell in. And then let's do also the today formula, and all that does is give me the date portion of today. Now these two are both volatile formulas, which means that every time I edit my spreadsheets, you can see that this one gets recalculated. And so there is a performance overhead there. If you had 10,000 of these now formulas in your spreadsheets, you would see an effect when they would all have to recalculate. So just worth bearing that in mind. Another useful one is this one called end of month. So EO month, and we say what's the date that we want to consider. Let's start with this one, and then how many months before or after the start date do we want to think about. And if we just put 0 there, then it just will give us the end of the current month. So you can see that's the 31st of October. And if I want to actually make this now the start date of the month, then what I need to do is go back one to the end. So that gives me the end of September. So I went -1 month back, and then I just add one more day to that, and it gives me the 1st of October. And we already saw the end of the month one. That was pretty easy. So we'll do end of month, and we'll grab that, and we'll say 0, and that gives me the end of the month. And that's how we get these date periods, which we'll be using in a moment in the report configuration. So let's keep going, and let's take a look at quarters now. So another common scenario is that we have some dates, and we want to just put these into quarters very quickly, and then perhaps even find the start and end dates of the quarters. And what we'll do is we'll just start by taking the month, because we're not interested in the day or even the year in this case. All we're interested in is the month. So let's take the month, Then let's divide it by 3. And let's just see what it looks like with all these different dates. And you can see that each different date now is going to give us a different result, a different month, sorry. And so if we round them up, then they are going to now correctly give us the quarters for each of these dates. So August is Q3, obviously. And the last thing we might want to do with this formula is to add in the letter Q just to really emphasize it's a quarter. And we do that very easily by just typing in the word Q in inverted commas and using the ampersand to concatenate it along with that round up. So let's copy that back down, and you can see that these are now correctly into their quarters. Now, one of the things we might want to do is to find the start and end of the quarter. So let's think about how we would calculate the end of the quarter for this date of May. Now, Q2 is obviously April, May and June. So it's 1 month past May, and then it's the end of that month we would want. So the formula would be end of month. This is the date in question, and then in this case we'd want to add 1 to it, and that would give us the 30th of June. Now, if we were to look at December, then obviously that's the wrong date there. That's not the end. We wouldn't want to add anything to December because that's already the last month of that quarter. And similarly, if it was January, then that's the end of January. That's no good. We'd need to add 2 in this case to get the end of the month in March. So what we want to do is either add 0, 1 or 2 based on whether the month is in the first, second or third position of the quarter. And if it's in the first position, we need to add 2 months to get to that last month. If it's in that third position, we don't need to add anything. So we just need to use a formula here that's going to get us that. And the formula is not dissimilar actually from what we were doing with to find the end of the month. So we'll do a mod, which is just gives me the remainder when I divide something. And what I'm going to do is divide first of all calculate the 12 minus the month, so how many months left, and then divide that by 3, and then take the modulo of that, which is the remainder of that division, and that will give me then the month at the end of the quarter. Let's copy that down, and then you can see that the August one is September, that's March, December, June, and March again. So that's looking pretty nice. To find the start of the quarter, that's pretty easy now. We'll use the same formula. We'll just pop that in there, and then we'll minus 3, so it goes back 3 months, and then we need to add 1 just to make sure that we get the first day of the new month, and we just need to format it the same as that one. So we'll use the paintbrush up there, and I can drag that down. So 1st of April, 1st of July, 1st of January, 1st of October, etc. So that's the months for the start and end date based on this date. So we've done all this work with the dates. Now let's see a practical example or use case for it. And that is when we are doing things, working with Google Analytics reports inside of Google Sheets. And this is something I do a lot of. And I use this Google Analytics add-on to bring my data into Google Sheets. And the first step is to set up one of these reports. And each of these columns is a report that says go to this profile, and based on this start date, this end date, or the last number of days, grab these metrics and dimensions and pull that data back for me. This is the next month, or rather the next report to do, the next one, etc. So you can see I've got a whole bunch of different ones set up. Might be this month, last month, this quarter, last quarter, this year, last year, that I can compare. So that's some of the most common ones. So let's go and take a look at the formulas to do that. So the end date of this one here is just going to be today because we don't have anything past that point. So that's just going to say, hey, the end date for this report for this month is whatever day it is today, because that's the end of the month for me, the end as far as the month goes. The start date is going to be the end of the month based on this date. We'll go back -1, and then we're going to add 1 to make sure it's the 10th, the 1st of October. Now then, so we want the first day of last month. So we will just do EO month. We can actually embed today right in there. And then we'll do -1, and that takes me back to September. So pretty easy. Then I can take this one back, and we'll do -2 now, and +1. And what that's doing is saying go back -2 months. That takes me to August. Then add 1 to just bump me back to the first day of September. And then Google Sheets, rather Google Analytics, will use these 2 dates to give me all the data back between the 1st of September and the 30th of September. Then this quarter, we saw this one already, so I'm going to copy this one in and just center it. So this quarter, and obviously again the last day of this quarter is just going to stay as today because we can't get data from the future. And the last quarter, we'll put that in and then just take a quick look at it. So it's giving me the 1st of July, which is the last quarter, and what it's doing is just instead of just subtracting 3 months this time, we're subtracting 6 months, and then we're going to add one to just bump us into the first day of that quarter. Then the end date for the last quarter is just the formula that minuses the 3 months. So we'll hit enter, and that gives me the 30th of September. Let's take a look at the year ones now. I'll just drag this report across. Now the year ones are a little simpler. Obviously the end date again is going to be today, and then the start is going to be the date, and we're going to take the year of today's date, and then it's the first month and the first day of the month. So what we're doing is supplying it with a year that we take from today's date, and then a month of one and a day of one, and then we'll hit enter. And last year it's exactly the same if we copy this, but what we do is we just subtract 1 year from that, and then for the last day of last year, which is the end date for last year, we'll change the months to 12 and the number of days to 31, and that gives me then the 31st of December. And that's it, folks. They are the formulas I wanted to show you. So we looked at date, year, month, end of month, doing some modular arithmetic to get the quarters. We looked at how dates are stored. That's the most important takeaway from this lesson, is that dates are stored as serial numbers. That's dates, folks. Enjoy the rest of your day.